Hey everyone. So Azure Event Hub here is a real-time data ingestion service. And so I figured since you can do real-time data ingestion, why not be able to do real-time data predictions with ML.NET? So that's what we're going to do in this video. We're going to use Event Hubs and then use ML.NET to make predictions on streaming data from Event Hub. So the first thing we need to do is, I'm in the Azure portal here, and we need to create a new Event Hub. So we're going to create a new resource, and I'll just type in Event Hub here. All right, so give it a name. I'll do, let's see, ML.NET Event Hub. That's available. Pricing tier, I'll just do basic. Put my subscription, put it into a resource group, and give it a location. And I'll hit create. So that might take a few minutes to create, and so we'll let that do its job and deploy. All right, so that deployed successfully. So let's go to it. One thing to note when you create an Event Hub here is that you actually create an Event Hub namespace, not exactly an Event Hub itself. So to do that, we'll click on this Event Hub add button here, and we'll give it its own name. Do ML.NET EH. All right, and we'll just create that, and that got created. We can go down here. All your event hubs will be down at the bottom here, and we'll click on that. And now this is where our event hub instance is. So we're going to leave this up because we're going to need this to get some connection strings and all that. Let's go to Visual Studio, and I already have a .NET Core console project loaded. All right, so in here I have a model folder, and inside that I have the housing model file already loaded, and we'll be using that for our predictions. And let's add some NuGet packages here. First we'll add ML.NET, and I'll use version 1.4 for this. And next I'm going to use Azure Messaging, Event Hubs, and Processor. That's so I can talk to that Event Hub that we just created. And last, I'm going to get system text.json. This is so we can serialize and deserialize JSON into string and all that. Feel free to use Newtonsoft if you're more comfortable with that. I'm just going to use Microsoft's implementation of it. All right, so remember when I said we need to get a couple things from our Azure portal here. Let's go ahead and create some constant strings for them. We'll do Event Hub connection string. And then we'll do an Event Hub name. So go back to our portal here. Our Event Hub name is what we created up here. ML.NET EH for Event Hub. For the connection string, we need to go to Shared Access Policies, and then add a new one. And I'm just going to do manage here, and I'll just give it a name of manage policy and create it. All right, so once it's created, we'll click on it, and then here is where we can get our connection string for the Event Hub, and we'll just paste it in here. In our main thread here, I'm going to get a consumer group, and that's going to be from Event Hub consumer client from the NuGet package that we just downloaded. A default consumer group name, and also need to get a storage client. We're using the new blob container client instance, and we get this as well. This comes in from that Event Hub NuGet package, so we don't need to do that separately. And then here we need to give it a blob storage connection string and a blob container name. I already have these defined up here in this blob connection region. We use this to pass into our Event Hub client, and this is mainly used to kind of keep track of all the events that have been read, so it doesn't reread any of those events. So next I'm going to create a processor with new event processor client. Control dot to bring in the namespace like the others. Now pass in the storage client, the consumer group that we created above there, and then the Event Hub connection string and then the event hub name that we created just up here. So that gives us a new event hub processor. And then with that, I can do processor dot process event async. And here I give it a method. So I'm subscribing to this method here, or subscribing to this event pretty much. And I'll create another method here called event or process event handler. And then also on the processor, we can call process error async. So anytime any errors may happen, we can listen to those and process them accordingly. And I'll create a process error handler method. So let's create these. Quick, do private static task and bring in that namespace. So the first thing I'll do, I'll just create the process error handler method here, and that's going to give us a process error event args parameter. And then here I'm just going to write out a couple of things. The partition ID, an error has occurred on it, and then I'll write out to the console the exception message. And since it returns a task, I do return task dot completed task, and it should be process error event handler. All right, do something similar to the process event handler method. And here it takes process event args as a parameter. And here is where we're going to do all of our work. And for event hubs, you need kind of two sets of code pretty much. This one we're doing here in C#, this is what we're going to be using to process new events that get into our event hub. And a little bit after this, we'll do another one where we actually produce events that goes into our event hub. That means we're going to have a payload that comes from our event hub. And to get that, we can get it from the event args here. It's going to be in the data body property. But this body property is a read-only memory of bytes. So we need to make that into a string of those bytes. And to do that, we do encoding that UTF-8, and let's bring in this namespace of the system.text namespace. And from there, it can call getString. That takes in an array of bytes, but because it's read-only memory of bytes, I need to call toArray on it. All right, so that gets me the string representation of the bytes data that comes in from our event hub. That's going to be a string, and we need it into our prediction output class that we usually do with our ML.NET models. And to do that, I'm going to use that system.text.json NuGet package that we used, and I'm going to call JSON serializer, deserialize into a housing data. So it'll be the input schema. Sorry, I think I said output schema earlier. And then pass in the payload to it. And now we need to create this housing data class. All right, so it's just like usual. Let me paste in what I had before, so you don't see me type in all this. There we go. This is pretty much the same thing that we see in the other videos where we deal with the housing data. We left the load column and column name attributes in. We probably don't need those, but I just left them in just for completeness. All right, so now that we have our data, let's first create a new ML context. Bring in this namespace. Now we're going to get the model, and to do that we'll do context.model.load, and this takes in a string of where the model is located, and that's in that model housing model.zip location that I showed earlier. And it returns out a data view schema of the input schema. Alright, so and now since we have our model, we can create a prediction engine using context.model create prediction engine. Use a housing data, and we need to create a housing prediction class as well. Pass in the model, and I'm going to pass in the input schema that we got from it as well. And so let's control dot and create this class in a new file. And this is just going to have the predicted house value as the score column. Alright, so with the prediction engine created, I can now create a prediction using that prediction engine and call predict on it, pass in the data, and then now all we have to do is we can write out to the console, and we just do prediction is prediction that predicted house value, and then I'm going to return task that completed task, similar to what we did up here. Alright, so that's our consumer app right here. Now I'm going to switch over to a Jupyter notebook and show how to use Python to talk to our event hub, and we can use that to create a producer script to give us our data to predict on. Alright, so I have Jupyter notebook created here. To be able to talk to my event hub and Python, I need a pip install Azure-event hub, and using the exclamation point here, I can run shell scripts, and I already have this installed, so that's cool. And a couple of imports here from Azure, the event hub.aio, import event hub producer client, and then from Azure.event hub, import event data, and I'm going to import the JSON namespace as well. Next, I'm going to create a variable to hold that connection string, and I can copy this once again. So next we do another producer with the event hub producer client, and then I can call from connection string and pass in the connection string from our variable there, and then I can also pass in the event hub name, which I'll get from here since we already used it. And we have the producer now, so now I can create some event data, and I can await on it in Python and call producer.create batch, and it's just a batch in our data and send it all at once, so we don't send it one at a time. And then I'm going to create a data object, and this is just going to be the housing data object, and I'll paste that in here. It's just some random data that I used. We'll call event data.add, and it'll be a new event data. And in here I'm going to use JSON.dumps and then pass in the data. So what this does is that it takes this dictionary data and then it dumps it into a string, into a JSON string. When you send in event hub data, it does have to be in a string, but you can pretty much give it whatever you want in JSON format. Right, so that adds to the event data batch. And next I can call await producer.send batch and then send in that event data. So let's go ahead and run this and send it to our event hub there. Alright, so that ran, so we should have a message in our event hub. Alright, so back to our consumer C# code here. We actually have to finish our processing steps. So we set up our processing event methods, but we have to tell the processor to start processing. And we use the start processing async. And then I'm also going to do a task delay and to wait seconds. We'll just do 2 seconds here. We'll wait 2 seconds before we tell the processor to stop processing. So we start processing, we wait 2 seconds for it to process, and then we stop the processing of our event hub data here. So let's run this, and we should pick up something here. There we go, so I picked up our item here. So we have our payload, there it is, and we'll deserialize it. But if we look at our data here, we didn't get that data deserialized correctly from what our payload shows. So let's see what's going on here. If we look at our housing data, when we deserialize it, it's going to try to match one-to-one from our properties to the properties in the JSON data. So since it doesn't match exactly, it's not going to parse correctly. So how do we fix that? We can use an attribute called JSON property name and give it the name that we expect that comes in our JSON data. So we use longitude, and this way it'll match on this JSON property name instead of trying to match on the actual C# property name. So I'm going to do that throughout the rest of these properties real quick. All right, so I have all the rest of the properties on here. Note that the median house value doesn't have that property because it's our label. So we don't expect that to come in our JSON data, so we don't need to map that out. All right, so let's run this again and see how this works. All right, so now I got it. We get the payload. So we got some items in it. It's deserialized, and let's make sure. Okay, so it deserialized correctly this time. I'll continue on here. Oh, and I forgot to add console.readline here. Right. But now that we ran through this already, let's send this data again as another batch, since it's already processed that first one. And let's run this again. It should pick up again. All right, so it picked it up. We'll continue on here. There we go. So now we have a prediction. That data predicted that house would be worth $266,000, and we can reformat this into currency if we wanted to. But I'll end things there. I just wanted to show how you can use nmall.net within streaming data coming from an Azure Event Hub. So thanks for watching, and I'll see y'all next time.